before we jump into the fourth phase of water, I'd love for you, because weather and all the impacts of weather are so prolific today. Tell us, tell us what's happening, Jerry. What is Mother Nature? What is Mother Nature telling us today?
So I claim no expertise in the change of climate, but I think I do know something about weather. I tell you, to my surprise, I was in an interview with an atmospheric scientist, and there was a break in the interview, and during the break, he told me, "I got to tell you a secret. You know, the atmospheric scientists, they don't understand at all two of the most fundamental issues that are related to weather and climate. First is evaporation, and the second is cloud formation. And you may have learned something about evaporation. So if you learned something, what you probably learned is that the water molecules evaporate by one molecule at a time, and they get a kick of energy. You can't remember kinetic energy, potential energy. You get a kick of energy, which releases them from the liquid water, and they evaporate. There may be some truth to this, but it can't be the whole story. And the reason it can't be the whole story is if you've ever gone to Starbucks or equivalent, and you see all the people around you and their hot coffee, you can actually see the vapor coming up. Essential basic physics tells you something. In order to see something, that something needs to be roughly the size of the wavelength of light. Now, the wavelength of light is a half a micrometer. A water molecule is so much tinier than that. And so just in the same way that you can't see the air because the molecules are so small, you can't see one droplet or one molecule of water evaporating. It has to be a giant cluster. And if you calculate how many water molecules are in the minimal size cluster in order for you to see it, I calculated it once. It was something like 1 billion or something like this. And the fact that you can actually see the vapor coming up means that the water that's evaporating to constitute that, it has got to be billions of water molecules coming up together. And, you know, that means that the conventional story of evaporation can't be correct, or at least it can't be complete. And so you might say that's a kind of starting point. And then you get to the issue of clouds. What is it that makes a cloud? So the principle is, it comes from the great physicist Richard Feynman, who many people consider to be the Einstein of the second half of the last century. He elaborated a principle, and it's called like likes like, because of an intermediate of unlike. So what on earth does that mean? Like likes like. It means if you got two charges, and the two charges are like charge, they're the same. Let's say they're negative charges. If I were to ask each one of you to predict, if you put these close together, what would happen? And I bet you that every one of you would say, well, of course, they're going to repel each other because they have the same charge. They're like charges. However, if these charges are sitting in water, the observation is they come together. They don't repel each other. Now, that would seem awfully mysterious, but Feynman figured it out. He said, if these two are, say, negatively charged, the reason they like each other, the reason they come together, is because of unlike charges in between. And what was missing from Feynman's assertion that this is the case is, where do you get these charges that lie in between, these unlike charges? Like likes like, they come together because of an intermediate of unlike. So you got two negative charges and positive charges in the middle that pull the negative charges together. And that principle, I believe, is the main principle underlying cloud formation. The clouds occur because these large clusters of water that have evaporated. They've got the same charge, negative charge, and they contain EZ water, which we haven't talked about. But when EZ water forms, it's negatively charged, and together with that is the formation of positive protons. And so you got these negative charges surrounded by negatively charged EZ water. Protons are released, and the protons have the highest concentration in the middle, so they pull these droplets, these clusters together, and that is one of the main underlying principles.
Yeah, let's come from the clouds down back to Earth, and let's come to our bodies, and let's talk about this fourth phase, this gelatinous phase of water, as you call it, EZ water. And could you share with us about how does that exist in our bodies? What is the function, and maybe in nature as well?
Okay, those are big questions. Question number one, it fills our cells. And it's a gelatinous, as you say, kind of water. We call it fourth phase water because its properties are different from every other phase of water that we know, solid, liquid, or vapor. And it's a kind of water in which the molecules are ordered. They're not, in liquid water, like the stuff we drink, the molecules are randomly oriented, and they're bouncing around a fierce number of times per second, or even per femtosecond. That's this water. But in the EZ water, or fourth phase water, we call it EZ because EZ is for exclusion zone, and it has to do with the fact that this ordered phase of water excludes everything. It's a pure crystal, liquid crystal. And the way you can determine that your body's full of it, and not liquid water. We learned from the textbook that our cells are filled with liquid water, but all you need to do is take a razor blade if you're brave enough, and cut yourself. So you cut yourself, and what comes out? So obviously blood comes out, but if your cells are filled with ordinary liquid water, then the water would come out in the same way as from a breached water pipe, and you've probably seen that. It comes out, but it doesn't come out of the cut in your body. And surgeons I've spoken to say the same thing. Deep inside our bodies, they'll cut through a muscle, for example, and the water doesn't come pouring out; it stays in. And so the reason it stays in is the water is this special type, and it's stuck to the solids inside the cell, so it stays in. It sticks like a gel would stick. It's gel-like. So now, in terms of function of this water, and I would like to assert that the function is to supply energy. Now, you don't ordinarily think of water as being an energy source, all right? But we found that it is, and we found in experiments that we did more than a decade ago, is that this water builds next to surfaces. If ordinary liquid water sits next to a so-called hydrophilic surface, water-loving surface, that liquid water undergoes a transition. It transitions to this fourth phase water. And to our surprise, we stuck electrodes in this fourth phase water, which can be pretty extensive. We stuck electrodes in, and we found out that typically this water is negatively charged. It's not neutral. So you start with neutral water, and the neutral water transitions to this negatively charged EZ water. And so there's something wrong here, right? Because you can't, out of something neutral, you can't get to something negative. The only way that could happen is if somewhere else there's something positive. And then we found that, indeed, that next to this negatively charged EZ, fourth phase water, sits protons, positive charges. So what's really going on is that the water is getting split it gets split into OH minus and H plus.
And last month we had a extraordinary man talking about Lauren Lockman talking about water fasting and how people can live on water fast for 21 days without any food whatsoever. Is the reason we can live on water alone because of this energy?
Yes, I think so. Just a few days ago, I spoke with a woman who goes by the name of Jasmuthine, who lives in Australia, and we're chatting, and she's been on a fast, so to speak, so it's called breatharian, eating no food for years and years. And she conducts actually a kind of a workshop or schooling for other people who want to go on this. And so there's been documentation from numerous people. I think she mentioned that in the whole world, she's aware of a few 100,000 people who do this on a regular basis, you know. They fast indefinitely. And so, of course, the question arises, the question you bring up, where on earth do they get their energy if they don't eat? Well, they can get their energy through light. And many of these people who do this are spiritually oriented people. And I wondered myself whether spiritually oriented people have maybe a higher capacity to absorb this kind of energy from the environment. And and if we're right that the easy water in the body is essentially a battery providing energy, and we've documented the use of this kind of energy in the body, perhaps that's all you need.
And you and I were talking about maybe the beginning of intelligence, Mother Nature's, for water's intelligence. So share with us what the water's intelligence and what is the foundation and power of that.
Sure. Well, I guess the first thing to say is that I don't think that ordinary liquid water has, if you say, intelligence or memory. And the reason for that is that water molecules, as I said earlier, they're randomly oriented and they're bouncing around, and it's hard to imagine a situation like that as having any capacity to store information. But easy water is different. Easy water has two features which make it capable. There are two features in your thumb drive that you stick into your laptop. It has a series of transistors, and the transistors are in a plane, a flat plane, and they're very well organized at the points of a rectangular grid arrayed over a large planar space. Oh, easy is like that too. It not only has order in a single plane, but the planes are then stacked on one another in an ordered fashion. So yes, it satisfies that criterion. The second criterion is that in the computer memory, the transistors have two states, and they're generally labeled 0, 1, or on, off, or whatever. And the memory is embodied in the fact that this array of transistors, some of them are zeros and some of them are ones in some distribution, and that's what constitutes the memory. Well, in the EZ lattice, you have oxygens and hydrogens, right? Because that's what water is made of. It turns out that the oxygens have not 2, but 5 oxidation states. And the one that's most common that we speak of, we call valence of -2. That's what we learn in school. But if you read any chemistry book, this is not exotic or controversial. There are actually 5 states: -2, -1, 0, +1, +2. So easy water has as much capability or more than a transistor array in a computer memory. So in theory, all of the elements that are required for memory exist in easy water. Now, Luc Montagnier, who won a Nobel Prize, and as unfortunately he passed a year ago, but he came to our conference every year for more than a decade, and he presented his results, and his results are astounding in terms of the capacity of water to store information. So, he took some DNA in water in a sealed flask and put it near pure water in a sealed flask. And the two sat next to each other for a day or so. And his hypothesis was that the information from the sequence of DNA was somehow being transmitted to the water and stored in the water. And then he took this water and he tested it using the PCR method, which people know about because of COVID. And he found indeed that when he combined this water with the ingredients that are in the PCR necessary for the PCR technique, the DNA that emerged had the same sequence as the DNA that had been sitting next to the water. Astounding.